Welcome back everybody, and in this lesson we're going to be learning how to use ASA and AAS to find congruent triangles. Chapter 10, Learning Another Way to Find Congruent Triangles. The two learning goals for today is explore and correctly understand the judgment methods ASA and AAS of triangle congruence, and can use the triangle congruence methods ASA and AAS to prove that two triangles are congruent. So here's our introduction. As shown in the picture, Shannon accidentally smashed a triangular piece of glass into 3 pieces. If she can only bring one of the pieces into a repair store, can she come back with the same triangular shape as the original one? If so, which piece should she bring? Can you explain why? So this problem we're going to be hovering with throughout the lesson, and at the end of this lesson, I'm going to reveal the answer. But, be thinking about it. Finding congruent triangles, ASA. Question. If you're told that two angles in one side of two triangles are equal, how many possible examples are there? So you know that there's two triangles, and two of those angles are equal, and one of their sides are equal. How many possible examples are there? So then, for example, this is a triangle, right? And then it could be this angle that's equal, this angle that's equal, and this side that's equal. So that's two angles on the side, and maybe one, this could be the angle that's equal, this could be the angle that's equal, but this is the side that's equal. Or this one. One angle on the side, another angle alone. So basically, this could be another one of saying how the side that's equal is the opposite side of one of the angles. So first to understand this, I want you to draw a random triangle ABC. Just any random triangle ABC. Then draw a triangle A prime, B prime, C prime, so that A prime, B prime is equal to AB, angle A prime is equal to angle B prime is equal to angle B. And then cut out the drawn triangle A prime, B prime, C prime, and stack it on top of triangle ABC. Are they congruent? Are they equal? Well, here's the procedure of doing this. First, you draw A prime, B prime is equal to AB. So over here we have triangle ABC, right? And then first our step of drawing the congruent triangle of triangle A prime, B prime, C prime is making the baseline, which is A prime, B prime. And we have to make sure that their lengths are equal. And then we draw angle D, A prime, B prime is equal to angle A. Angle E, B prime, A prime is equal to angle B. Angle A prime D, B prime E intersect at point C on the same side of A prime, B prime. So here's how we do it. So first we draw angle D, A prime, B prime is equal to angle A. Here. Then angle E, B prime, A prime is equal to angle B. And then A prime D, B prime E intersect at point C prime on the same side of A prime, B prime. And then there you have it. We have triangle A prime, B prime, C prime. Think, what pattern can you find from it? Knowledge point. The method of ASA. Text. Two triangles, text representation. Two triangles with two angles and their corresponding sides are equal. Abbreviated as ASA. Because the A represents angles, S equals side, and angle is equal to, and A is equal to angle. So it's saying two triangles who has two angles and one side that's equal, and it's the side clipped in between two angles. And this is a example. And in geometrical language representation, it would be in triangle ABC and triangle A prime, B prime, C prime. Angle A is equal to angle A prime given. AB is equal to A prime, B prime given. Angle B is equal to angle B prime given. So, triangle, remember this is the sign for so, triangle ABC is congruent to triangle A prime, B prime, C prime, which is ASA. So we would write it in this form when we want to express this sentence right over here in geometry. And remember, when we listed out all our reasons for it, we had a bracket over here. So let's do example 1. Given that angle ABC is equal to angle DCB, angle ACB is equal to angle DBC, prove triangle ABC is congruent to triangle DCB. So first I want you to try this on your own. Okay, then you come back. Let's look at the solution. So in triangle ABC and triangle DCB, angle ABC is equal to angle DCB, that's given. And BC is equal to CB, that's their shared side. So BC is equal to CB, this is their shared side. And that angle ACB is equal to angle DBC, that's also given. So triangle ABC is congruent to triangle DCB because of the rule ASA. So what's our two angles in this point? So the two angles is angle ABC, angle DCB. BC and CB, that's their shared side right here, in this case. So that would be the S. And then angle ACB and angle DBC would be the other angle. So angle ACB, and angle DBC. So as you can see, this is an example of ASA, that this is how ASA would work in real life problems, because if you remember, ASA is very helpful when it comes to finding congruent triangles. Finding congruent triangles, AAS. Question. If the two interior angles of a triangle are 60 degrees and 45 degrees, and the side facing 45 degrees is 3 centimeters, can you draw this triangle? So we're trying to draw a triangle, and we know that one of the two interior angles of the triangle is 60 degrees. So here is our 60 degrees. And another interior angle is 45 degrees. Then the side facing this 45 degrees is 3 centimeters. Can you draw this triangle? So out of this angle, and this side, that's 3 centimeters. I should write that. 3 centimeters. Can you make a triangle out of it? Think. What are the similarities and differences between the conditions here and in the conditions in 1? Can you convert it into the conditions in 1? So over here we have angle 60 degrees. And then over here we have angle 45 degrees. So actually, this red line over here comes over down over here. That's 3 centimeters, right? This 60 degrees comes over here to this 60 degrees, and then that can make a triangle. So here's a conclusion. Two triangles whose two angles are equal and the opposite sides of a set of opposite angles are equal are congruent, abbreviated as AAS. So in triangle ABC and triangle A prime B prime C prime, this is an example. Angle A is equal to angle A prime. Angle B is equal to angle B prime. AC is equal to A prime C prime. These are all given. Remember the bracket? So that means that triangle ABC is congruent to triangle A prime B prime C prime because of the rule AAS. The two angles in AAS, remember AAS means angle, angle, side. So it's that two angles in one side of two triangles are equal, and it's two angles next to each other with a side on next to them. So we look at this. What are the two angles that are equal? That would be angle A, angle B, right? And then we see that over here. We see that. And then the side that's given is AC is equal to A prime C prime, so AC is equal to A prime C prime, and that can help us figure out that triangle ABC is congruent to triangle A prime B prime C prime because of AAS. Now let's apply what you have learned. As shown in the picture, Shannon accidentally smashed a triangular piece of glass into 3 pieces. If she can only bring one of the pieces to a repair store, and can she come back with the same triangular shape as the original one? If so, which piece should she bring? Can you explain why? So using what we learned, here's the answer. Bring piece 1 because two triangles with two angles and equal sides are congruent over here. So because why would we bring piece 1? Because in piece 1, two angles are known and one side is known. So that would be ASA. Now let me explain why the other ones wouldn't work. So let's first look at 2, okay? Pretend there isn't any 1 and there isn't any 3, because remember, she can only bring one of these to the store. So there's 2, right? Then, when we try to make a triangular piece out of it, sure, on the right side over here, we know to connect at a point, but we don't know how far to extend over here. It could go on forever. So that's why 2 does not work. Why does 3 doesn't work? Let me first shade out 1 and 2 so we can focus on 3. 3 doesn't work because it's the same thing as 2. It already has a point over there, but it doesn't know how far to reach out. But 1 is different. 1, first of all, you already have these line segments over here that it tells you this is where you're supposed to stop the line segments. And then all you have to do is keep continuing the line segments down until they meet one another, and then you have the whole triangular piece. So that's why piece 1 would be the answer. So here's our class summary. Today we learned all about ASA and AAS. So the content was that two triangles with two angles and sides corresponding to the same equality, abbreviated as ASA. Application. Provides a new method to prove that the line segment and the angle are equal. And notice, pay attention to the positional differences between two angles. This is unmathematical language over here. Two angles and sides in ASA and AAS. And here is the 2 skills we learned today. Explore and correctly understand the judgment methods of ASA and AAS of triangle congruence. Can use the triangle congruence methods of ASA and AAS to prove that two triangles are congruent.